Today, we're going to break down the exact bulletproof strategies you need to handle errors gracefully. We're going to make these complex concepts just click, so let's get into it. So let's kick things off with a scenario we've all probably run into. You build a shiny new multi-agent system, you push it to production, and boom, a standard tool fails. Maybe it's a database timeout. Now, this isn't traditional programming, right? There's no standard try-catch block here to save the day. So when a language model hits an error and doesn't have an explicit error block, what do you think it actually does? Yep, it confidently returns absolute garbage. No hesitation. We literally call this the silent killer of agentic systems. See, when an error happens and the agent doesn't explicitly know it happened, it just silently plows ahead. No crash, no alert. Because the error gets swallowed, the model thinks, great, that was a success, and it just hallucinates the rest of the results. It's a total nightmare. All right, so here's our roadmap for today to fix this. We're going to cover the silent killer of agents, the 4 types of tool failures, smart recovery and escalation, the tool overload problem, mastering the tool choice flag, and finally, building a bulletproof agent. Let's jump in. Section 1, the silent killer of agents. Okay, so the ultimate cure here is the is_error flag. If you're using the Model Context Protocol, or MCP, they give us a super clean fix for this. When a tool fails, you absolutely must set that is_error flag to true. It explicitly taps the LLM on the shoulder and says, hey, something went wrong here. Now listen closely because this is a massive anti-pattern, and for sure something they'll try to trick you with on the exam. Do not just return an empty array on failure. If you do that, the agent treats it as a success. You gotta use the flag. Without it, your model is flying blind. Moving on to part 2, 4 types of tool failures. Easy. Categorizing our enemies perfectly dictates how we recover. We basically have 4 types here. First, transient errors. Think network timeouts. These are just temporary hiccups, so yes, they are completely retriable. Then we have validation issues, like passing a bad input parameter. These are sometimes retriable, assuming the agent is smart enough to tweak the input based on the error message. But then we hit a brick wall. Business logic violations, like trying to authorize a refund over $500, and permission access denials. These are never retriable. I mean, there's 0 point in just hammering a system when the core policy explicitly says no. Pinning down this "is it retriable" distinction, that's a huge, high-value signal for passing your architect exam. Which brings us to Section 3, smart recovery and escalation. Look at the stark difference here. On one hand, you get a generic operation failed, literally a dead end. A coordinator agent looks at that and has absolutely no idea what to do next. But when we swap that out for structured metadata, game changer. By explicitly passing a category, like transient, setting is retriable to true, and throwing in a retry after delay of 2,000 milliseconds, suddenly our coordinator has an actionable battle plan. It knows exactly what broke and exactly how long to wait before trying again. And that feeds right into this idea of local recovery before escalation. It's kind of like having a junior customer service rep. When they hit a snag, they don't instantly run to the CEO, right? They try to fix it themselves, locally first. It's the same thing here. When a tool fails with a transient error, the sub-agent should catch it and try a couple of local retries. It's only when those local options are completely tapped out that it escalates that structured error up to the coordinator. Seriously, terminating your whole pipeline over a single untried failure is a classic all-or-nothing anti-pattern. We want graceful degradation. All right, Section 4, the tool overload problem. Take a look at the number 20. Now, intuitively, you'd probably think, hey, if I give my agent 20 different tools, it's going to be super capable and versatile. But actually, the reality is the exact opposite. Giving it too many tools just forces the model to overthink its choice at inference time. If tool descriptions overlap even a little bit, or if the names sound similar, the model's confidence just tanks. This tool bloat actively ruins selection reliability, and you end up with the wrong tools firing all the time. So the fix is scoped tool access. You literally only give the agent the tools it needs for its specific job. Period. For example, if you have a synthesis agent whose whole job is writing and double-checking text, it really just needs a verify fact tool. It doesn't need full unrestricted web search capabilities. Leave that heavy lifting to the research agent. Scoping isn't just about security or permissions. It's about giving your agent a clean, unambiguous tool set so it doesn't get totally confused. Section 5, mastering the tool choice flag. When scoping isn't quite enough, we have 3 main parameters to lock down execution control. First is auto, where the model decides entirely on its own if it even wants to use a tool. Then there's any, which forces the model to use at least one tool, though it still gets to pick which one from its list. And finally, tool, which forces it to execute a specific named tool, like lookup_order. Now, here is a trap you have to watch out for on the exam. You absolutely must use any when the requirement guarantees structured output generation. Doing that forces a tool to fire, and it stops the LLM from going off script and just chatting with the user instead of doing the actual work. Finally, Section 6, building a bulletproof agent. Okay, to wrap this all up into a truly bulletproof architecture, you have to ruthlessly eliminate these sloppy design anti-patterns. Memorize these 3 things. 1. Never silently return empty arrays on failure. Always explicitly use that as error flag. 2. Do not terminate pipelines on a single untried failure. Let your subagents try local recovery first before escalating. And 3. Stop giving subagents generic, unscoped tool sets. Keep them hyper-specialized to protect that selection reliability. So, I'll leave you with this final thought. Think about your own code base right now. If your AI agent hits a failure today, is it acting like a junior rep, silently panicking and returning garbage? Or is it a senior agent, gracefully catching structured errors, retrying locally, and orchestrating a seamless recovery? Go audit your pipelines, implement these flags, and you'll be well on your way to mastering reliable agentic systems.